Right, so in the last video we looked at the idea of a definite integral, and that essentially will allow us to calculate the area under a curve. Okay, so I'm going to look at this curve here. It says the diagram below shows the sketch of the curve with equation y equals x squared plus 2. Okay, and it says the shaded region, okay, obviously this is shaded here, is bounded by the curve, okay, the x-axis and the lines x equals 1 and x equals 3. Okay, so that's how we describe those vertical lines. Yeah, x will equal 1, x equals 3. So this area is bounded by the curve, x-axis and these two lines here. So they want us to actually find the area of this shaded region. In other words, the area under the curve, yeah? Area under the curve between 1 and 3. Okay, so how do we go about that? Well, we use this process of integration. So quite simply, okay, we need to integrate, okay, the curve, which is x squared plus 2. Okay, so we see that there. With respect to x, but because we want the area, we need to put then the values that we're working out the area between, because, you know, I could be asked to go from here to here, okay, or even wider area. But it's just between these values. X is 1, x is 3. So you put the lower limit here, we call them limits, right? And then the upper limit here, so it's between 1 and 3. So how do we go about it? Well, remember what I said in the last video, okay? With a definite integral, when we're working out the area, you do not need to write a plus c, okay? You don't need to do that, okay? But you still integrate as normal, okay? So we're going to integrate that as we've done already, and it'll be quite straightforward. But because there are limits there, what we do in our answer is we put it in a box, right? And a square box, okay? So it has to be square brackets. So you integrate this, x squared, add 1 to it, so you get x, add 1 to the power, so you get x cubed, yeah? Divide by 3, and then 2 then becomes 2x, okay? And then you close that bracket and you put these limits at the end there, okay? So remember now, there's no need to write plus c. Okay, and then we're actually going to work out the area, and it's really straightforward. What you do is you start off with the upper limit, the upper value here, the one on the top here, and you substitute it in, okay, to the whole thing here. So you literally put in 3 cubed divided by 3 plus 2 times 3, okay. Is that all right? And what might be nice is, because this is like two terms here, I've substituted in 3. Let's just sort of put it in a bracket, just a big bracket, just to make it sort of clear there, okay? So we put that upper value in, right, here. Okay? We also got to put the lower value in, but what you must do is you've got to take it away. You've got to take away. So when you put the lower value in, make sure you minus it here. Okay? So you put 1 in there, and then 2 times 1 there. Okay, it's a bit like the range, isn't it? When you work at the range, it's like highest, take away the lowest, isn't it? And you're always going to do that process. So what you do then is you get your calculator and you can work it out. Okay, so maybe work out that bracket first. So fraction 3 cubed over 3 plus 2 times 3, and that comes out to be 15. Take away then, let's put that in, 1 cubed over 3 plus 2 times 1 is obviously 2, but I'll put it in for completeness sake, and I get that there, so 7/3. So all I've got to do then is perform that calculation, so 15 take away 7/3, and I get my answer out to be 38 over 3, okay? So we leave it as a fraction, basically, okay? 38 over 3 is, what, 12.6 recurring, so that area is literally 12.6 recurring, okay? 12.6 recurring, that will be the area there. Okay, in terms of like units, there's no need to write units, okay, because we're not bothered about that, right? They don't say if it's in centimeters or anything, because we're dealing with grid work here, okay. But if you really wanted to, you could put units, you could put that down units squared, isn't it? When we do area, we put squared. You could write that if you wanted to, okay. But ultimately I want that answer there, and we've literally worked out the exact area underneath the curve there by using integration, and it always works.